now that we have the operations and parentheses, now that we know how the numbers can interact with each other, we can derive some properties. And all a property is we're given some definitions, we're given some rules to it. Properties in math are just kind of consequences that happen because of these definitions. And because we don't have to do much extra work to do the properties, these are things that we can just start assuming once they're listed or proven or whatnot. So the first property of these operations that we are going to work with is called the commutative property. Yeah, sure, why not? Property. The commutative property says that we can rearrange numbers and it doesn't change the answer. We can take two numbers, let's call it A and B. That's the same thing as saying B plus A. So this is probably something that you've known, but didn't quite understand the strength of the statement. And it's important to know these things for when we start doing actual algebra with it. Something that is not commutative is subtraction. If subtraction was commutative, it would look like this. Let's start with 5 minus 3 equals 3 minus 5. 5 minus 3 is 2. 3 minus 5 is negative 2, so they are not the same thing. Therefore, subtraction is not commutative. But we can say that multiplication is commutative. That's pretty easy to see. A times B equals B times A, 5 times 3. They're both 15. Using a similar argument, you can't say that division is commutative. A divided by B is the same thing as B divided by A. Sometimes, but not necessarily all the time. So here I will say 15 over 3 is the same thing as 3 over 15. And this is 5, this is 1/5. So division is not commutative. This is more properly called the commutative property of addition and multiplication. Then there is the associative property. And I'm not going to go through and prove it this time, but it will be formally known as the associative property of addition and multiplication. For similar reasons, you cannot do the associative property for subtraction or division, because it'll just change the problem in a way. What is the associative property? Well, this is where the parentheses start coming in. Like parentheses, obviously that there's an order to it, but sometimes that order doesn't matter, and this is what the associative property says. If we were to have... Hi, Bellatrix. If we were to have three numbers that are being added together, but I wanted you to do the first two first, and then add on the third, that's the same thing as saying I want you to add the second two together first, and then add that first number. This is true in general. It doesn't matter in what order you do the additions of a string of additions, it's going to come out to be the same answer. So, real quick, an example, 4 plus 3. Stop it. Stop it. Bellatrix, this is all your fault. You know that, right? Yeah. I'm sure your purring is doing wonders for the audio. So, get out of here. Come on. See, Oliver, he's a good boy. He doesn't do anything. But I wanted you to do these two first on this side, and these two first on this side. Well, let's see what happens. 5 plus 4 is 9. And then 9 plus 3 is 12, and I'm sure you're already ahead of me. on this, we got 5 plus, do these guys first, so 7, and then 5 plus 7 is 12. I know that this isn't like a cool formal proof, but it's just an example to show you what's going on here. And then similarly, multiplication is associative. So we'll do A times C. I'm not going to do an example, but for similar reasons, you can multiply things in any order as long as it's all a bunch of multiplications. From this point, you can see that multiplication and addition are very lenient when it comes to what they do. But they've always been separate from each other. Like, this is just additions, this is just multiplications. This is a bunch of additions, this is a bunch of multiplications, but they're separate. But there's a property here that actually combines them together in a really neat way. So this is called the distributive property. You're going to be doing a lot with the distributive property in your math career. Doing it in various forms, really messing with it and tricking it and nitpicking with it to do things that you couldn't normally do, because that's just how powerful of a property this is. Don't get me wrong, you're going to be doing all of these, but the distributive property is the one that can kind of be expanded on the most. So what is it? Like I said, this is combining addition and multiplication and parentheses, actually. So we have A times B plus C. And I should have mentioned this from the start. These A's, B's, and C's and all these other things, they can be any real numbers. It doesn't matter what they are, it'll work with any real numbers. If you've never seen anything on the outside of parentheses like this, it's just kind of sitting there. There's no operation, there's nothing telling me what it's doing there. This is assumed to be multiplication. So from now on, if I do that, if I just write a variable or a number right next to a layer of parentheses like that, it's assumed to be multiplication. This is the same thing as taking that outside number and multiplying it by each of the inner things, and then, but those things are separated by the plus. So A times B plus A times C. The A is hitting both of the things on the inside. A lot of people, when they're learning this, use this, draw little hump arc things to remind yourself kind of what you're doing there. So, an example. Sure, 5s, 3s, and 2s. Sounds like fun. So this should be the same thing as A times B. Now notice here I do have to put a times between these two constants. I know I just said that putting something next to some parentheses like this, or even these two variables next to each other, there's no operation there, it's multiplication. But I do have to do that for two constants, because if I didn't, then this just looks like 25. So if you're multiplying two constants together, you do have to signify that. But otherwise, if a constant is next to a variable, or two variables are next to each other, or the parentheses thing, they're all multiplications. And then 2 times 3. Let's see if these two things are the same. So on this side, my preference has me do the parentheses first. So I'm going to do 2 times 5 plus 3, which is 8. And then 2 times 8 is 16. Let's see if that's the same on this side. We got 2 times 5, which is 10, plus 2 times 3, which is 6, and then 10 plus 6 is 16. There is an order to doing these operations, funnily enough, called the order of operations, and I'm going to cover that in a minute, but trust me, you have to do the multiplications before the additions. You can't just go in a line like that. So yeah, these are both equal to each other. Again, just another a little example to show you that the distributive property does hold.